All right, so we're going to jump into talking about real-world problems dealing with quadratic functions. Right? And we're going to go through 4 examples here on dealing with that. So let's look at this first one here. So we got television screens are described by their diagonal measurement and by their length to width ratio. So many widescreen televisions have a length to width ratio, usually called the aspect ratio, of 16 to 9. If you have a 40-inch widescreen television with an aspect ratio of 16 to 9, could you fit it in a piece of furniture with an opening that is 37 inches by 24 inches? Okay, so with this, now that we've got this, we already drew out the picture there, already kind of drawn out there. So we're going to go ahead and label this so we can see what we got to do with all this. So to start out with, we know our aspect ratio it gave us is 40. So we know we got that as 40, so we're going to put a 40 right here. So our diagonal right there is 40. Now with this, with a 16 to 9, we're talking about length and width, right? So your length, of course, is longer. So you're dealing with your 16x and your 9x, because we don't know the true width of it overall as far as what that x is going to be when you're multiplying that 9 and that 16 by to get the true measurement in inches. Because we know that we have 40 inches for the diagonal for the actual measurement of the aspect ratio. All right, so let's do this and solve for that x. Now, again, additionally, it looks like a TV, you think of a box, but we're going to talk about triangles here, okay? And dealing with that Pythagorean theorem, we're going to talk about a squared plus b squared equals c squared. Okay, and we have a, b, and c, okay? So technically we have our, so label a right there, we have our b here, we have our c here, okay? So let's do this. So we should have 9x squared plus 16x squared equals 40 squared. Now let's just do a little math and get this all figured out. So to do this, we should get 9 times 9 is 81. I have x squared. Plus, as well, we've got 16 squared is 256. And then I have x squared. And then 40 squared is 1600. All right, so now we combine like terms over here. Since we have both these are x squared, and that's going to give us a 337. It's 81 plus 256 is 337 x squared, and that's going to equal 1600. Now we need to solve for x. So what we do? We need to divide by 337. So let's go ahead and divide by 337 on both sides. Now to get rid of it here, I'm just going to leave it in fraction form for the time being. There's to put it on the decimals. With this setup right here for 1600 divided by 337. And then to get rid of that squared, we're going to take the square root of both sides. So we'll be left with x equals plus and minus the square root of 16 divided by 337. Okay? And when we put that in the calculator, you're going to come out to get a value of around plus and minus 2.18. So x is going to be plus and minus 2.18. Now, for x value being a negative, it would be kind of pointless, right? In the real world setup, you can't have a negative value of negative inches here in the actual x value with that. So we're going to go ahead and use positive. We're going to go ahead and use positive 2.18. So that'll help us with determining our overall width and length of this TV that says it has got an aspect ratio of 40. So let's find our length. Let's take 16, that's 2.18, and that's going to give us 34.88 inches. And then if we take 9 times 2.18, that's going to give us 19.62 inches. All right, so our dimensions are approximately, so let's write this out. So our dimensions are approximately, so we got 35 by 20, right? So again, got 35 inches by 20 inches. All right, so we'll give a little bit of wiggle room because that's an actual screen. And imagine, there's a little bit of, width of the actual TV outside of the screen, the plastic that holds in that actual crystal screen there going forward with it, right? So with that, we got 35 by 20 on that. And so we're looking at to see if we can fit it into 37 by 24. Well, in that case, with having this being less than, our value being less than 37 by 24, then yes, we can fit the TV. So yes, we can fit that TV in the opening. Fit the TV in the opening. All right. All right, so let's do another one. All right, so you can grow 4 pounds of wheat per square meter of farmland. If you grow 3,600 pounds of wheat on a square farm, what is the length of the farm? Okay. So for this one, let's draw a picture. It says we got a square farm, right? So we got a square farm here. Okay. And now with this, it says you can grow 4 pounds of wheat per square meter of farmland. So to do this, let's see how we can break out or break down this farmland area. So since it says we have 4 pounds per square meter of farmland, so if we were to break this down into having So if we're to break this down into having your little square meter set up for it, right, that'll give you 4 pounds of wheat. Well, we don't know exactly how long each of those sides are. It just says square meter for the farmland. Well, we don't know what all that plays out to be and how long it's actually be for that setup. But we do know that we can make a formula out of this because it says if we go 3,600 pounds of wheat on your farm, what is the length of the farm? So we know that we take 4 pounds for our x times x, right, to get our square meter. And that, we want it to equal, for the setup, we want it to equal 3,600 pounds. So again, that can be written as 4x times x is x squared equals 3,600. Well, now we just do a little math to solve for x. So we're going to divide by 4 on both sides. Okay, and the 4's go way over here, left with x squared. And that's going to leave us with 900. 36 divided by 4 is 9, so let's have a couple zeros with it, so 900. And then we're going to need to take the square root of both sides, right, to get rid of that square. So we take the square root of that, square root of 900. That gives us x over here, and that should leave us with plus or minus square root of 900 is going to be 30. Okay. Well, in this case, we don't want to have our x value saying we have a negative 30 meters. That wouldn't make any sense, right? So you want to have x to equal positive 30 meters for the setup for your x value. In this case, that is going to be our length is going to equal 30 meters. Because we'd have to have 30 meters long here, all right, to be able to make our 3,600 pounds of wheat. Put a little box around that guy. Okay, so let's do another problem. So you're moving to a different apartment and you need tops of the boxes that contain the items you want to keep. So you decide to create open box tops by cutting out the corners of square pieces. Let me reread that. You decide to create open box tops by cutting out the corners of a square piece of cardboard and folding the edges up. If 4-inch squares are to be cut out of the corners and the box has a volume of 400 cubic inches, what are the dimensions of the original? Okay, so we know our little squares are 4 inches for each side there. Okay, and we want to know what is the dimensions of the original cardboard. So for this, like I say, we know that we got 4, right? So you got 4 here and 4 here. So it's play with all of those, right? All those little boxes right there. So that's going to play out. In which case, we are seeing here that overall, the length, shall we say, this length right here, we'll just say x because we don't know it. Okay, the other thing we need to take away from this, since we're dealing with volume here, we're dealing with a volume setup, we know we can do length and width, but we need to know the height, okay? Because again, volume is going to equal length times width times height. Well, they've given us what they're talking about on how long these sides are, as well as to do that, we're folding up the edges. So we fold up these 4-inch squares that are going to be cut, right? So therefore our height is going to be 4. So our height is going to be 4. Now for our length, with that, as well as our width, because they're going to be the same, right? So we're dealing with a square box, square piece of cardboard, square piece of cardboard. So we know length and width are going to be the same. Well, to find our x value, we would need to be able to take this x minus our 8, right? Because you got 4 over here and 4 over here. So to actually find out the value that's in here, right, we need to take what we call this all x and then minus 8. So x minus 8 for both of those. Okay, so now we just need to multiply these out because we also know our volume. So we've got our volume, we've got our length, we've got our width, we've got our height. So we can say 400 equals our length of x minus 8 times x minus 8 times 4. So now when we multiply this out, we can simply do this. Let's go ahead and divide by 4 first. Let's get rid of that 4, so we don't have to mess with that. The x is an 8, so let's go and get rid of that. So let's divide by 4 on both sides. So the 4's will go way over here, and 400 divided by 4, of course, is 100. And then we're left with x minus 8 times x minus 8. So now, since these are the same, we can simply say we have 100 equals, in this case, these are both the same, right? So x minus 8 squared. Well, let's take the square root of both sides so we can get that x by itself. So take the square root of both these sides here, and we'll be left with plus or minus 10 equals x minus 8. Now I need to determine whether we use a plus 10 or minus 10. Well, if we're going to use a minus 10, if we did this and we said negative 10 equals x minus 8, our x value would equal negative 2. So again, we would have negative inches for our box, and that wouldn't work, okay? So we need to use a positive 10. So we're going to say positive 10 equals x minus 8. So our x, well, let's go ahead and write that out. We add 8 to both sides. So that 8's go way over here, and we're left with 18. 10 plus 8 is 18 equals x. Okay, so now let's find the new dimensions that we're going to have to deal with. Since we already know what the equations are for those values, our height is going to be 4 still, all right? But our length and our width are going to be x minus 8. Well, we know height is still going to be 4. Length is going to be 18 minus 8, which gives us 10. And width is going to be 18 minus 8, which gives us 10. So for this, our new dimensions are going to be length times width times height. So we're going to have 10 inches times 10 inches for length and width times our height, which is 4 inches. Those are our new dimensions of that box. All right. Let's do another one. All right, so for the last one here, we'll say you have a 25-foot ladder and you lean it against a wall such that it reaches up the wall 17 feet farther than the distance from the base of the ladder to the wall. What is the distance from the base of the ladder to the wall? So what we're looking at here, so we need to draw this out. So we've already kind of drawn it out here, drawing like a little triangle, right? Our ladder leaning against a wall. And it says we have a 25-foot ladder. So that's our first key number we need to look at. So we know this guy right here is 25 foot. Okay. Now it says that you lean it against a wall such that it reaches up the wall 17 feet farther than the distance from the base of the ladder to the wall. So we don't know what this value is right here, from here to here. And they say that it is 17 feet farther than the distance from the ladder to the wall at the base. So we're simply going to say x plus 17. So now we can use that equation again of a squared plus b squared equals c squared. Okay. Because again, we have, in this case, we can go ahead and say our a value is x. We can say our b is x plus 17, and our c is 25. So with this, we can say x squared plus, let me say x plus 17 squared, and then that'll equal 25 squared. Okay, so now let's do some math to get this thing solved out here. So with that, can't do anything else with the x squared, so we're going to leave x squared there. Now if we take x plus 17 times x plus 17, and you do that math, you will come out to get x squared plus 34x plus 289. Okay, because we have x times x was x squared, and you're going to have 17x plus 17x, which gives you 34. Then 17 times 17 is 289. That's a quick little easy way to do it when you've got two of the same that are right by each other. That's the way you can think about it, okay? And 25 times 25 is 625. Okay, so now let's go ahead and get this simplified a little bit. Let's go ahead and combine like terms and get a 0 on one side of there so we can solve for this x. So we'll combine these x squareds first. So we take care of these guys right here. We'll take 2x squared plus 34x plus 289 equals 625. We need a 0 over here, so let's subtract 625 from both sides. Those go away to give us 0. So we're left with 2x squared plus 34x. And that's going to give us minus 336 equals 0. So now let's go ahead to get a 1 over here, I should say, for our x squared, right? Because we want to get it to where we can factor this out easily. Let's go ahead and see if we can factor anything out of these guys. And it looks like if 34 is divided by 2 and 336 divided by 2, and of course 2 is divided by 2. So let's go ahead and divide everything by 2 so we can factor that 2 out. So in that case, we should be able to say, I'm going to draw it up here and get it going. We can simply go 2 times, so we factor out a 2 there, we should get x squared plus 17x, and then minus 168. Okay, and that still equals 0. So now we can take everything and divide by 2 and get rid of that 2 over there. So therefore the 2's go away, and we'll be left with our x squared plus 17x minus 168 equals 0. Okay, so now we can do our big X to find out how to factor this guy out and what it turns out to give us. So if we do that, in which case our A value is 1 for this setup, our B value here is 17, and our C is negative 168. So A times C is going to give us negative 168. And we need to add up to our B value of 17. So what can we get for that? Well, with these numbers, we should be able to get 7 times 24 will give us 168. Okay, and if we make the 7 a negative, when we add them up, that should give us a positive 17. Okay. So therefore, we should get, when we do this, we do write it up with bottoms up right there. So we should get x minus 7 times x plus 24, and that equals 0. So now we can put both these equal to 0. So x minus 7 equals 0, or x plus 24 equals 0. So we get x equals 7, or x equals negative 24. Well, like we've been talking about this, you can't have a negative length here. We can't have negative 24 feet below the ladder to the wall, so that is out of the question. The negative 24 is gone. So we know that our x value has to be 7. And it was asking, what is the distance from the base of the ladder to the wall? So it wants to know that x value in general, because that's all that is for that setup right there. So for the answer to this saying, we're going to say 7 feet. That is your answer. All right, so I hope you learned a little bit of something with this. Again, draw the picture That's the easiest thing to do when they give this types of problems with real world setups, with boxes, triangles, ladders, whatever they throw at you. Draw the picture and then label your sides, label the distances of whatever you've got to draw out there. Therefore, then you can put together a formula to solve for your missing variable. All right, guys, I'll see you next time.